Good afternoon, my YouTube viewers. Crystal here. I just wanted to make another video with a code review for something that I was working on all day yesterday. And so I wanted to do a code review on this and go over it with you so you can look at the code. And I'm also going to be making a blog post on this. And when I make the blog post, then I will leave the link to the blog post for another video that I'm going to make. So if you want to get the code, you're going to have to actually read the blog post to get the link to the GitHub account for that. But in the meantime, we'll go ahead and do a code review on this code that I've been working on. So what we're going to do is we're using this Our World in Data CSV file, and this file is updated every single day. So since the file is updated every single day, what you have to do is every day that you're working on the code, you have to make sure that you have uploaded the most current version of the file. So that's what I had to do. So every morning I get up and I upload the most current version. And that's what I have to do to make sure I'm working with accurate, current, up-to-date data. So what we're going to do is we're going to compare the US, the UK, China, South Africa, and Sweden. So we're comparing the US because the US is a superpower, and we want to know how the US is faring with this pandemic. And also, I was born in the US. And we're going to look at the UK because I live in the UK, number one. And two, a strain of the virus that is much more contagious has come out of the UK. And as a result of that, it has resulted in a travel ban from the UK. We're also going to look at China because there's a lot of controversy about this, but people believe that the original virus came out of a lab in Wuhan, China. So we're going to look at China and see how China's doing with regard to this virus. We're going to look at South Africa because the virus has mutated in South Africa. So there's a South African strain of the virus. Now, this strain from the UK is much more contagious than the original strain, and the South African strain is also much more contagious than the original strain. And we're also going to look at Sweden because Sweden didn't have a lockdown. So we want to see how Sweden is doing in comparison with the other countries because it didn't have a lockdown. Now I'm going to be doing other comparisons as well, but I'm just going to compare these different countries for the time being. And then perhaps I've already got decided that I want to compare China and Taiwan, and I'll go into that when I do the comparison. And then I want to compare like maybe Sweden and Denmark because Denmark is like right next to Sweden. Sweden didn't have a lockdown, but Denmark had a lockdown right away. So we want to compare these two countries, one without a lockdown and a neighboring country with a lockdown. So I wrote this program on Google Colab, which is a free online Jupyter notebook, and it has most of the libraries that you're going to need already installed on it. So the only thing that I had to do was I had to import Pandas and NumPy, and you can do a lot with Pandas and NumPy. And what I might do at some point is I might find all of the functions from Pandas and all of the functions from NumPy, and then try to write a program and say, well, we're going to write a program using only NumPy, and we're going to write a program using only Pandas, so we can see what we can do just using Pandas and NumPys. So we loaded our data set. We've got the data set from Our World in Data. I loaded the most current version, so which was yesterday, was 30 December 2020. So you can see that I'm loading the most current version as of yesterday. But what happened was Bulgaria went and put in a row saying 31 December 2020. And because Bulgaria has done that, then it sort of wreaked havoc on our data. And as a result of that, I had to go through and do some more coding to try to correct what Bulgaria has done by putting a code in saying 31 December 2020. Now what we want to do is we want to check the information on this data set, and you can see that we've got some object files, but most of them are float, which is numeric. So now what we want to do is we want to convert the date to a number. So date equals train date. Train date equals PD to date time. Train date errors equals coerce. Train date num equals train date dot dt strf time, and then the format train. So you can see what we've done is we've taken the actual date, which was the date that the information was recorded, and we converted it to a number. And the reason why is we converted it to a number is because that's what the model wants to see, is a number. So what I wanted to do is I wanted to see how many countries were covered in this data set. So country equals train location to list. So I created a list with all the countries in it. So the list country is blank for I in country. If I not in list country append. So what we've done is we've appended the name of every country that's not already on the list. And so we've got a list of 192 country names, but for some reason one of the country names has dropped off, and I'm not sure exactly which country name dropped off and why it did. So originally there's actually 192 country names, but when we go through and do the analysis, there's only going to be 191. So one of those countries has dropped off, and I don't know which one. So what we want to do now is we want to get the latest date. So we want to import date time. We want from date time import date and time delta. And so basically what has happened is Bulgaria went in and put in today's date, which they should not have done that, because what they should have done is they should have just kept it at yesterday's date. But because they put in today's date, then that sort of messed up our analysis. And because it messed up our analysis, I had to rewrite the code. So today equals date today, and today is 31 December 2020. And yesterday equals today minus time delta, days equals 1. And then so yesterday was 30 December 2020. And so last date equals train.date max. So the last date is 31 December 2020. And the reason why is because Bulgaria went in and put in 31 December 2020, which they should not have done. And so it sort of messed up the data set. And it says print type last date. And so that's a timestamp. And so we've got some other code that I had used, but I didn't need it this time, but I didn't want to totally discard it. So I just made it remarks because I may need it at some time in the future. So I don't want to throw away the code just in case I need it sometime in the future. So yesterday equals PD timestamp yesterday, and you print what type it is, and it is a timestamp. And again, we've got some more code for yesterday, which we don't need it at this time because it's a timestamp. But even though we don't need it, I decided not to get rid of it just in case I need it at some other time. Said from date time, import date time, time delta. Next day equals yesterday plus time delta, days equals 1, and you print next day. So next day is 31 December 2020. So that's tomorrow. So now we do last date equals train date equals yesterday, and then last date. And then so you can see the last date is 2020 12/30. So the train has to equal yesterday to get it to do that. Now we do a graphical representation of the new cases. So you can see all the new cases. Graphical representation of the new deaths. Now what we've done is we want to check the new cases by country. So you can see all the new cases by the country, and you want to see all the new deaths by the country. So now what we've made is a box plot of new cases. So you can see all of the new cases. You can see all of the new cases, and North America has the most cases, and I think that's probably because they're doing more testing. Next thing we want to do is we want to check new deaths, and North America seems to have the most deaths, but you do have some outliers in South America. Now we've got a heat map, and so if you're interested in heat maps and you like to analyze how the different independent variables relate to each other, then you've got this heat map that will go into detail and analyze that for you as well. So now what we're doing is we're analyzing the country. The first thing we're doing is we're going to check the United Kingdom. So here's the code for the United Kingdom, and we put some code in there to filter out the United Kingdom. So we look at the new cases in the UK, and you can see that we're in the middle of a pandemic. This strain from London or the UK is really taking its toll on the UK, and you can see in the graph that we're getting more and more new cases because this new strain that's come out of the UK is very highly infectious. Now we want to look at the new deaths in the UK, and again you can see the deaths in the UK are increasing because this strain is very infectious. So now what we're going to do is we're going to look at new deaths per million, because that's the basis that we want to look at, because whenever we go through and we analyze the new cases and the new deaths, what we need to do is we need to find out how many new cases per million or how many new deaths per million, and then that enables us to compare one country against another. So you can see they've got lots. The deaths are increasing because of this new strain of the virus. Now we're looking at the United States, and we have filtered out the United States. You can look at the new cases of the United States, and you can see the new cases are on the rise as well because some of the strain from London has actually made it to the US. And then now we look at the new deaths. You can see that the new deaths are on the rise as well. And now we're going to look at deaths per million. And you can see that the deaths per million are increasing. Now what we're going to do is we're going to look at China. And the reason why we're looking at China is because that's where people believe that this virus originated. There's some controversy about where it actually originated, but I believe that it was released from that lab in Wuhan, China. So now we look at the new cases in China. Oh, look, isn't that amazing? They had a spike at the beginning of the had a spike at the beginning of the pandemic, and now look at that. There's hardly anything at all. Now we're going to look at new deaths per million. What was that? That was new cases. Now we're going to look at new deaths per million. And so we had a spike towards the beginning of the pandemic, and then now look, there's nothing at all. And this is what I was watching a YouTube video, and they said that in China, what they do is if a person dies and they have a secondary illness, like let's say they have heart disease or lung disease or diabetes, then they will put on the birth certificate that they died of the secondary illness. So if they have heart disease and they get COVID, they'll say that they had heart disease. If they have lung disease and they get COVID, they'll say they had lung disease. If they have diabetes and they get COVID, they say they have diabetes. So what they're doing in China is, in order to keep the figures down, if a person dies, they just say that they died of this secondary illness. So then they don't have to say that they died of COVID. So now we're going to look at South Africa. And we filtered out South Africa. So you can look at the new cases of South Africa. And as you can see, the cases in South Africa are increasing as well. And the reason for that is because there's a new strain of the virus out in South Africa. And it's supposed to be more contagious. These strains in the UK and the US are supposed to be more contagious. Now we look at new deaths per million, and you can see that again, the new deaths per million are increasing as well. So it's always important to look at the new deaths per million. So now what we're doing is we're looking at Sweden. And the reason why we're looking at Sweden is because Sweden never had a lockdown. But I'm going to be comparing Sweden with its neighboring country, Denmark. And so you can compare that, how two neighboring countries, one had lockdown and one didn't have lockdown. And you can see how they fare with regard to the cases and the deaths. So Sweden originally didn't have any cases, and now their cases are escalating. And I was watching a YouTube video, and it said that the King of Sweden actually admitted that they had made a mistake by not having a lockdown, because you can see that their cases are escalating. And then the deaths from COVID are escalating as well. So now what we're going to do is we're going to compare, we're going to do a comparison. So what we want to do is we want to compare the new cases per million to the new deaths per million. So there's a lot more new cases than there are new deaths. And that was globally. And so what we're doing with the U.S., we compare the new cases to the new deaths, and there's a lot more new cases than there are new deaths. In the UK, we compare the new cases to the new deaths, and there's a lot more new cases than there are new deaths. So now what we're going to do is we're going to actually compare the countries. And how you compare the countries is you have to take the country, you have to decide which countries you want to analyze, and then the country, you have to take the last day of, take all the countries, you write down their first day that they started keeping records. And the last day that they started keeping records, that's when you start your analysis. So in the UK, one of the countries, I can tell you which one it was because I have it written down. It was South Africa. They did not actually start keeping records until 7 February. And since South Africa did not start keeping records until 7 February, 7 February is the day that we start this analysis. So UK started keeping records on 31 January. So that means we have to take off 7 rows. So that's what we've done, is we've taken off 7 rows to get the start date of 7 February. We did the same thing with the U.S. We took off 16 rows because the U.S. started keeping records before a lot of the other countries did. We checked China. With China, we take off 16 rows as well because China started keeping records before other countries did. And then with Sweden, we take off 6. We take off 6 rows because they started keeping records on 1 February. So now, what we've done now is we're just checking shapes, and all the shapes are 328. And then now what we're doing is we are creating variables for a data frame that we're going to create. And so the first thing we do is we take the date equals revised UK COV19.date.values. So you have to put the values, because if you don't put the values, your data frame's not going to work very well. So we created all of these variables for the UK, US, China, South Africa, and Sweden for the new cases per million and new deaths per million. And we created all those variables. So now what we've done is we created a data frame with the date and the new cases per million, new deaths per million. We created a data frame for the US with the date, US, new cases per million, new deaths per million. We created a data frame for China with the date, new cases per million, new deaths per million. We created a data frame with South Africa in the date, new cases per million, new deaths per million. And we created a data frame with Sweden with the date, new cases per million, new deaths per million. And what we've done is we've created one large data frame out of that, and we have merged these 4 data frames together, and we've called it compare. And the thing is that the thing that you need to keep in mind is that you're only allowed to merge 2 files together at one time. So in order to merge all of these 4 files, we had pd.merge UK compare, US compare on date, .merge C compare on date, .merge SA compare on date, .merge S compare on date. And then so you can see the compare, you can see how we've got all of these columns quite nicely in our new data frame, because we have to put everything in one data frame if we want to be able to compare. So now what we want to do is we want to check for any null variables. And so we've checked for null variables. All of the null variables are in numeric columns because all of the columns except one is numeric. So we replaced all the null variables with 0. So now we've plotted compare, and you can see we plotted the new cases per million for the UK, the US, China, South Africa, and Sweden. So China's down there at the bottom because of the way that they record their data. They're not recording that they're having new cases, so they're down at the bottom. And Sweden is up there at the top because Sweden didn't have a lockdown. And because Sweden didn't have a lockdown, more people are dying. So I don't know if Sweden's going to implement a lockdown or not. And then so you've got the rest of the countries, South Africa, US, and UK are in between the two. So now what we're going to do is we're going to check the new deaths per million. So you can see that China's down there in the bottom because of the way they record their deaths. When they record a death, they say that they died from the secondary illness. And so they won't say that they died from COVID. And then you've got Sweden, because Sweden didn't have a lockdown. Sweden's really got a lot of deaths. And then you've got the US, the UK, and South Africa in between China and Sweden. So that was interesting, don't you think? So now what we're going to do is concludes our analysis, but we're going to go ahead and carry on with the program, the code review, until the end of the program. We don't have that much to go. So now what we're going to do is we're going to check our null values with the train file. You see there's quite a few null values. So train equals train drop date. We want to impute the missing values. And then so what we want to do is we want to take all of the columns that are not numeric columns. So we use code to do that. And we impute all of the null values with a code that says not listed. That just makes a different category for it. And so now everything that is left is numeric. So all of the numeric columns that have missing values, we just put 0 there. And now what we're going to do is we're going to ordinal encode all of our categorical columns, because the model will not work if there's any strings or timestamps or anything like that. It can only be numeric. Now what we do is we define our x and y. So y is train.new deaths and x is train drop. Anything to do with the total deaths and anything to do with the new deaths. Now, after we've defined our x and y, what we're going to do is we're going to put x on the standard scaler. So we standard scaled our x, and now you can see y, and you can see x is an array now because it's been scaled. And now what we're going to do is we're going to use train test split to split our train data set, and our validation set is going to be 10%. Now what we're going to do is we're going to select our model, and I selected the Hist gradient boosting regressor because that's a very good model. It gave us 99.5% accuracy when we trained and fitted our model. Now we're testing on the validation set. So when we tested on the validation set, we had an 88.28% accuracy. Or we predicted on the validation set. We had an 88.28% accuracy. So you can see y-val, and you can see y-train values, and you can see y-pred. So now what we've done is we just made a little chart, and it's not a very good chart either, but we've made a little chart where you can compare the predicted values against the validation set. So we've taken our predictions and we put them on a data frame so you can compare the predicted deaths to the actual deaths. So now what we do now is we have to create our test data set. So test equals last day dot copy, test dot date equals next day, and then test. So our last day is December 31st, 2020, our test file. So that's going to be tomorrow. Or actually it's today, but it's going to be tomorrow when you'll find that out. So we're going to convert the date to a number. So test date num equals test date, dt strf time format test. And then what we'll do is we'll come over here and you'll see the last column is a number because we have actually converted the date to a number, which is what the model wants to see. We're going to test for any null values, and we've got loads of null values. So we did exactly the same thing that we did for the train file. We did predict date equals test date, test equals test drop date, axis equals 1. And now what we want to do is we want to filter out all of the columns that are not numeric. So we filtered them out, and then what we've done is all of the null values we've just replaced with not listed to create an extra category. So now, since the only thing left is numeric values, now we can say fill in A with 0. So all of the null values are now going to be replaced with 0. So now you've got your test file going up to the next date. It doesn't say the date because it's been dropped, but let's look over here. The test file is 31 December 2020, so it was actually converted to a numeric value, even though the date was dropped. So what we do now is we put all of the object columns in an ordinal encoder. So we've ordinal encoded all of those object columns. So now what we define our X test. And when we define our X test, the features are going to be exactly the same features that we had on X. And we have to drop a whole lot of columns because we want to drop anything to do with new cases, and we want to drop anything to do with new deaths. So all of those columns are dropped. So now we put X test under a standard scaler, so you can see the X test was scaled. Now what we do is we predict on our X test, and we put our predictions in a data frame. And so you've got your country, you've got your predicted date, and you've got your predicted deaths. So what you could do if you wanted to is tomorrow what they're going to do is they're going to update this CSV file. And if you wanted to, you could go through and you could check the predicted dates against what was in the CSV file and find out how accurate it was. So that concludes this code review. If you like my code review, please like, subscribe, and share. If you like the work I do and you want to leave a donation, I'll have my email address to my PayPal account in the description box down below, because I do not have enough subscribers, so I cannot monetize, and I can only ask for donations to make money on this channel. And thank you so much for watching this video, and I look forward to making more videos for you.